Hi, this is Kenny Lee, and let's talk a little bit more about vectors. In this video, we're going to talk about the resultant vector, which is simply the result of adding two vectors together. In one dimension, it's actually really easy. So let's say we have a displacement vector going this way. Let's say it's 5 meters. And then on top of that, that person continues in the same direction another 3 meters. In which case the resultant vector, which I'll draw in red, is from that first vector all the way to the last one. So that's a total of 8 meters. So the result is they're 8 meters to the right of where they started off from. But let's say they go the other direction. Let's say we got another 5 meters this way for the second person, and they come back 3 meters. Well, the resultant vector for that one, again I'll put in red, is just 2 meters. They're only 2 meters to the right from where they started from. But that's pretty easy. That's just adding and subtracting. If they're going the same direction, add. Going opposite direction, subtract. What happens if they're at right angles to each other? So we've got two vectors here. 10 meters per second going, let's say, east, and then another 8 meters per second going north. Now I drew this as more of a vector diagram. In a vector diagram, you always draw the first vector, and where that one ends, draw the second vector. And the resultant is from the first vector to where the second vector ends. So that's my resultant. And the angle is always between that first vector you draw and the resultant. So for this example, we've got these two vectors, and we want to know the resultant and the angle. So that's actually pretty easy because we're just using the Pythagorean theorem, where it's a squared plus b squared equals c squared. A lot of times we change that up and say r squared for resultant equals a squared plus b squared. You can use a c there if you want. It won't make any difference whatsoever. So, and it doesn't really matter which one's a and b in this case. So we got 10 squared plus 8 squared. We got 10 squared plus 8 squared gives me 164. But that's not the resultant. We need to take the square root of that. And so we get 12.8, let's call it 1 meters per second. That will be the resultant velocity if these were our two vectors. And to find the angle, we simply would use, well, we could use any trig function to tell you the truth because we know all three sides, but it's best to use tangent because the opposite side and the adjacent side was given in the problem. So tangent is the best choice for figuring out the angle. That way, if you messed up on that, it won't affect this calculation. So tangent of theta, opposite will be 8, adjacent will be 10, so that is 0.8. So we want to take the arctangent or inverse tangent of that. Let me write that in. And so 0.8, take the arctangent, we get 38.66 degrees. So if I want to write that out as a vector, I would say my resultant is 12.81 meters per second at 38.66 degrees. And if we were doing north, south, east, west, that would be north of east. There we go. Now usually you won't have it already drawn out. Usually the statement will be in words like this one. Sort of like a pirate map. Person walks 100 meters due west, turns and goes 200 meters due south. What's that person's displacement? I always recommend drawing the horizontal one first. Whether it's given in the problem first or not, I always like drawing that one first. So we're first going west. So if we had our coordinate system set up, we're going to go west 100 meters. And then from that spot, we're going to go south 200 meters. And we're looking for his displacement, so we're looking for the resultant of from where you start to where you end. And we'll also be looking for that angle. And so it's the same procedure, Pythagorean theorem and tangent. So r squared equals a squared plus b squared. So 100 squared plus 200 squared. So that is 5, 0, 0, 0, 0. And then we take the square root of that, and we get that the resultant is 223.6, let's call it 1 meters. And for the angle, we would just use, again, tangent. So tangent, opposite over adjacent. So tangent would be, opposite side would be 200, adjacent side's 100. So to get the angle back, we're going to have to use the inverse or arctangent of, well, 2. And so 2, that is going to be 63.43 degrees. So if we write this one out, our resultant is 223.61 meters at an angle of 63.43. That's going to be south of the west line, so south of west. Instead of a displacement or a velocity like we've been doing, you can also use this for forces. And for this one, let's take a look at this. We got a box being pulled by 2 ropes that are making a right angle to each other. One tension is 30 newtons sideways. So if we draw this, there's my box. 30 newtons, let's say going this way, so let's call that sideways. The other one is 45 newtons. It has to be at a right angle, so it's either got to be up or down. I like trying to keep things in the first quadrant, so we'll say that's 45 newtons right there. And I want to know the resultant force. Well, if we've got that box, this one's pulling up, this one's pulling sideways, this one's stronger. So the force on the box is going to be more up than out. But this is not really a good picture because we don't know angles and stuff like that. But as you've seen in a previous video of mine, we can slide these vectors around. So what we can do is redraw that picture as a vector diagram. Again, I like to do the horizontal one first, 30 newtons, and then the vertical one, 45 newtons. And we want the resultant, which goes from the first one to the last one, r and theta. Now, again, it's the exact same process, Pythagorean theorem and tangent. So r squared equals a squared plus b squared. 45 squared plus 30 squared equals 2925, but that's r squared. Now take the square root, and we get 54.08 newtons for the resultant. And then the angle, we use tangent. Pythagorean theorem and tangent go together, just like sine and cosine go together. So in this case, I'm going to look at my vector diagram. So the opposite side's 45, adjacent's 30, 1.5. So my angle is going to be the inverse tangent, or arctangent, of 1.5, which is 56.31 degrees. Since this is a force, we don't have to worry about north, south, east, or west. It's just going to be R equals 54.08 newtons at 56.31 degrees. For forces, you just put the angle from that horizontal line counterclockwise around to your vector. So let's get one that's a little bit more interesting. All right, we've got a boat crossing a river. And so there's a lot of different ways this problem could be set up. For this first one, the boat can go a velocity of 15 meters per second, and the river is always flowing south at 6 meters per second. So the first one, what's the resultant velocity of the boat going downstream? Well, downstream means the boat is going with the river. So if the river is going south at 6 meters per second, and the boat's also going south at 15 meters per second, then the resultant velocity is just those two added together. So the resultant velocity would be 21 meters per second. So R equals 21 meters per second. In this case, it's south. Well, on part B, now it's asking if the boat's going upstream. Well, the river's still flowing south at 6 meters per second, but the boat will be traveling upstream, so that means north at 15 meters per second. So the resultant velocity will be from where you started to where you ended, so that's going to be 9 meters per second. So on this one, the resultant velocity would be 9 meters per second. And since we're going upstream, it'll be north. That's a curious question. What if the river was flowing 15 meters per second down, and the boat was traveling 15 meters per second going upstream? What would happen? Well, the boat would stay in the same place. Its speed from the shore would look like 0. It would just sit there. So for this last one, we've got the boat traveling east, the river still going south at 6 meters per second. The boat is going east. And so if we draw the two vectors from the boat's perspective, obviously I'm not drawing them to scale, it would look like that. And the boat's going to travel a little bit more east than south. But we want to draw a vector diagram to make things a lot easier. So for that one, again, I prefer drawing the horizontal one first, 15 meters per second. And where that one ends, draw the vertical one, 6 meters per second. And the resultant velocity is, again, from where you start to where you end. And the angle is from that first vector to your resultant vector. Pythagorean theorem and tangent again. R squared equals A squared plus B squared. So that's going to be 15 squared plus 6 squared. Squared. So 15 squared plus 6 squared gives me 261. But I want R, so I'm going to take the square root. And so that is 16.16 meters per second. And for the angle, tangent of theta is opposite over adjacent. So tangent of theta is going to be 6 over 15. 6 divided by 15 gives me 0.4. So theta will be the inverse or arctangent of 0.4, which is 21.8 degrees. And so my resultant would be R equals 16.16 meters per second at, let's see, that was east and we're going south, so we're going south of east. 21.8 degrees south of east. Thank you for tuning into this video. Stay tuned for more vector videos and other physics content. Goodbye.